Screen share. Siapa? Do you get anything on quantum world? Hambali, tak dengar suara dia ni. Kau tak keluar suara, tak tahu kita jumpa dah kali ni.
Yes, later.
Jumpa apa quantum world?
Jumpa macam sandwich je.
Apa?
Dia track the free carrier to the sandwich.
Apa benda?
Dia track the free the two dimension.
Okay. So what is it? Apa benda tu?
Itulah quantum world.
Apa?
Itulah faham quantum world macam dia track confine the free carrier into the specific place.
So one of the job of a quantum world to confine the carrier to a specific place. Yes. Great. That's a function of quantum world. What is it actually?
Tahu tak?
Dia ni apa, defect ke, dia ni titik ke, dia ni material line ke, apa benda dia? Okay, Faiz pula jawab.
Quantum has a potential with only discrete energy values. So sini tengok dia punya the position is like almost the same as the what is it? The depletion region, but what it states that only what Hambali said before, it's only confined.
Tu function dia. Apa benda dia sebenarnya? Apa benda dia? Azam.
What is quantum?
Azam.
Yes, madam.
Apa benda
Saya tengah
quantum
cari,
world?
madam.
Tengah cari lagi. Aina. Internet udah okey Aina? Last time asyik terkeluar je.
Kat UIA dah.
Oh, kat UIA. Welcome back. Okay, so pastinya okey lah internet awak. So, apa benda quantum world?
Based on Hambali said just now, first tu it is used to free the.
Jangan repeat. I don't want something repeat. Just add what's addition. Jangan sebut sama dengan Hambali. Apa benda dia?
Okay, it is changes the 3D model 3D to 2D by forcing them to occupy the final regions. And it is used to decrease. It is a potential well with discrete energy values.
Wow. What is discrete energy value?
Habis.
Huh?
Sempat copy the next sentence.
Awak faham tak benda
so
baca? Apa benda?
So it's actually a physical layer of different material compared to the semiconductor material that were used for p-n junction. So we have p-n junction, and then we got the physical layer in between them.
Physical layer.
So I take the quotes here. Quantum wells are heterostructures in which a thin layer of one semiconductor is sandwiched between two layers of different semiconductor material.
Okay, explain your own words.
So we got like P and N type of semiconductor material. Usually we just put them together, right, to form a p-n junction. But quantum will take a step further by inserting a very thin layer between those two materials.
How thin is very thin?
I believe, is it nanometer, something like that? 20 nanometer?
Okay, close. So let's share. I will start drawing. So dia tak susah pun konsep quantum ni. Okay. Dia macam kalau if you understand the fundamental dan semiconductor, sepatutnya tak susah nak faham. Sebab tu kena faham yang saya duk ajar selama ni tu, jangan menghafal. Make sure you understand. Okay. If you remember, we talk about yang dulu kan macam ni, yang ini apa nama ni, yang saya draw energy band. Okay, this is conduction band, this is valence band. And then here you have many layers, right? Energy state, energy level. So this electron here can go anywhere. Dia boleh move. Dia boleh jump sikit ke sini, ke sini, ke sini. It can go everywhere. Seperti dia, it's not confined. Tu nama dia is not confined. The electron can go everywhere, and also the same here, the hole also can also move everywhere. So it's not confined to a space. Now, it is not so good because when it's not confined, because kalau kita ada PN junction, okay, kalau kita ada PN junction lah, saya draw forward bias lah. Let's draw forward bias. Forward bias. Ada forward bias ni. Forward bias. Tidak. Finish. So we have P, and then you have N. Like this. Okay, let's say this is forward bias PN junction. So this electron over here. So for example, an LED, you forward bias the PN junction. It will go over here, right? The electron will go from the N to the P, and vice versa the hole. So this electron, and then you want it to recombine in the middle. So bila dia sampai kat sini, recombine with the hole, then release light photon. And if you put, for example, you put 5 electron over here, if it's 100% efficient, the whole, all the 5 electron will recombine and get 5 photon, right? That is 100% efficient. Okay, that is what we want. That we put this amount of energy, we get everything. Okay. However, when it's a bulk semiconductor, okay, ni nama dia bulk. Yang sama-sama ni saya ajar awak ialah we call it bulk semiconductor. Bulk semiconductor means dia memang besar lah. The dimension is big, like micrometer. Micrometer is already called bulk semiconductor, whereby the carriers are not confined. The carriers can move everywhere inside the semiconductor material. So when it's bulk semiconductor, in terms of this PN junction over here, so this electron here have a choice. So this electron can go over here, or this electron can also go over there. Can move here, can move there. It can move along here. So the probability, so right now we talk about probability. You remember Fermi level, the probability to find free electron. This the probability of when the carriers are not confined, the probability of the electron to recombine in this region is less. Sebab dia ada tempat nak pergi tempat lain. Okay, so it's not confined. The electron suka hati nak pergi mana-mana, right? So so even if they go here, let's say if this electron go here, it can go to the P without recombining. Because for LED, we want all the 5 to recombine. But now the electron can pass over, dia tak recombine, boleh pergi sini. Because of it's not confined, dia boleh gerak ikut suka hati dia. Now, as an engineer, we want to find a way, is it possible that the electrons here, we confine it here. Kita suruh dia duduk kat sini, jangan bergerak. So confined meaning it's confined means the electron will be staying there. If the electron are stuck over here, the probability of recombination over there will be higher. Okay, so that's the aim, to confine the carrier so that we can control lah electron tu akan duduk kat situ, maka probability of recombination will be higher. Now, so that's the aim. So how to do that? That's how they invented the quantum. Well, dia start dengan quantum wire. Kalau nak baca, dia start quantum wire, quantum well, then quantum dot. Okay, so mana cerita dia ni? So jadi okay, so a bulk semiconductor macam ni, biji seketul. This is bulk, which is the electron are not confined. The electron can move Next is, I will not talk about quantum wire. I will go straight to quantum well. So that no longer we no longer use quantum wire and not efficient. So people go direct to quantum well. So quantum well, what happens is macam Faiz cakap, katalah kita tak bulk semiconductor. So this is bulk. We put another bulk. It can be the same material or different. For example, kalau kata ni gallium arsenide. Ni gallium arsenide. Dua material bulk ni. Tapi tengah-tengah dia, kita cantum dia macam kuih lapis lah. It's like kuih lapis kita buat dua. Tapi tengah-tengah ni kita letak a very thin layer. So ni kira thin layer of another material. And normally the other material has a lower band gap compared to the other yang sandwich dia. Maknanya inti dia tu, quantum, this is the quantum level. Ni saya tengah ajar awak cara paling senang nak faham. Kalau baca buku, dia tak guna perkataan saya lah. So, just for you to understand the concept. So the quantum well is the middle whereby it's very thin. Normally in number hundreds of nanometer. Thin, thick. Dia punya thickness dia tu 100 nanometer. Yang ni biasanya bulk ni normally 1 micrometer ke. Okay. So can you imagine? So this the quantum well material, it has to be a material which is a lower band gap compared to the sandwich yang ni. So maknanya kalau gallium arsenide, what's the apa nama ni band gap of gallium arsenide? Normally it's 1.4 eV. So we need to find a material which is less than 1 eV. So we can put here indium arsenide. So indium arsenide is a, kalau tak silap dia punya, saya guess ni, kita tak sempat nak check. Indium arsenide, let's say the bandnya is 0.8 eV. So it's smaller. So you can see here, kalau tengok ni, this is actually quantum well is a heterostructure. Sebab tu Faiz kata awak belajar dulu kan, homo junction, homo structure, heterostructure, homo junction, heterojunction, right? It just means that hetero, one and more than one type of semiconductor material. So here it's already more than one type. So we have gallium arsenide, then you have indium arsenide. So
0.354 je ni, madam.
apa?
0.354.
0.3. 0.3.
Yeah, for the indium arsenide.
Okay. 5 eV. So 0.35 eV. So it's much smaller. But remember, if you want to make heterostructure before, kan saya pernah ajar kelas, it has to be lattice match. So the whatever you want to do quantum well, the material that you want to do the sandwich must be lattice match. And plus the syarat dia, it has a lower band gap. And another syarat, it has to be very thin. Okay, now it has to be very thin, 100 nanometer. You can have heterostructure without quantum well. How? So saya nak tunjuk ke awak. So kalau saya buat macam ni, 1 micron, 1 micrometer, 1 micrometer, gallium arsenide, indium arsenide. Although it looks the same, but this is not quantum well. Why? Because the dimension. The sandwich must be very, very thin, of 100 nanometer per scale. So what happens? Okay, now let's understand the physics of what happens if you make it very thin here. Okay, if you make it very thin here, what happens? So what happens is, now to explain what happens, we need to draw in terms of energy band diagram. I give you 2 minutes. Draw me the energy band diagram of this. So this is P, this is N. And the indium arsenide is intrinsic. Draw me the energy band diagram for this. I gave you already the band gap value. Apalah. Saya makan cereal je awak menulis. Saya bercakap tapi awak jangan dengar saya. Saya nak makan cereal je. Saya lapar. Saya makan cereal dengan buah je. Makan
I have
nasi.
a cup of coffee for this morning.
Kopi. Tak
Instant
bagus. Awak minum
Nescafe.
kopi saja. Breakfast is the most important meal.
Yeah, but I become coffee addict basically.
You know Hassan Al-Banna kata, jangan minum kopi. You know who is Hassan Al-Banna?
Heard this name before, but again, never like search into it.
Tak pernah dengar?
No, I've heard his name before, but never like go into detail again.
Siapa tahu Hassan Al-Banna siapa?
Pengasas Ikhwanul Muslimin, the founder of Ikhwanul Muslimin.
Siapa Ikhwanul Muslimin tu?
Hmm. Organization that want to revive the Islamic teaching in Egypt.
Good. How do you know about this?
I don't know how I know.
You don't even remember how you know? Yes, Hassan Al-Banna is the founder of Ikhwanul Muslimin, and he is a very big, organization that wants to revive Islam. So Hassan Al-Banna dia ada banyak buku, banyak speech dia ditukar jadi buku, and one of the speeches that they give to the Ikhwan was jangan minum kopi sebab dia caffeine is not very good for the health. Saya tak minum kopi. One of the thing that they advise untuk orang Islam yang tu untuk perjuangkan agama ni lah, and then dia kata kena check, your kesihatan, kena check darah every year. So since I learned that sejak saya umur 27 ke, saya akan check darah every year sampai sekarang. So kita nak bawa Islam, kita kena sihat. Kalau kita sakit, kita tak boleh bawa agama kita.
Then how do you keep yourself awake?
Oh,
Just sleep early.
true. Sleep early. Sleep early. I never sleep later than 12 o'clock at night. Saya akan tidur masa belajar dulu, tak pernah saya tidur lewat daripada 12 o'clock to 12 o'clock. Tapi saya akan bangun awal. Kalau saya perlu bangun awal. Tapi biasanya saya akan make use of efficientkan time masa saya. So saya tak akan buat benda merapu lah. And then satu lagi, you need to ask Allah for barakah of time. Ya Allah, assignment ni bagilah aku buat dalam masa yang sekejap saja. Kalau orang lain buat 5 jam, ya Allah bagi aku buat dalam sejam tapi tip top. Allah boleh buat. So saya dulu macam tu lah. Saya belajar sungguh-sungguh. Memang pelajar tu memang tak ingat dunia. Kalau duduk tepi saya pun saya tak akan perasan awak ada kat situ. Saya akan belajar sungguh-sungguh. Tapi I make it very efficient so that saya tak tidur lambat. So kalau tidur lambat, esokkan saya mengharu lah. I cannot concentrate in class. So I will sleep early. Saya bagusnya dari Islam, you sleep early. Then you wake up early. Bangun untuk qiyam, belajar masa tu. Payahlah medal. Memang payah. Ingat senang nak masuk syurga. Masuk syurga payah. So kita kena lawan lah. Dah siap lukis?
Almost.
Siapa dah siap? Azam dah siap?
Dah, madam.
Awak nak share? Macam mana awak nak share? Awak ambil gambar, atau awak share? Boleh ke? Macam mana nak buat?
Saya lukis kat pen je, madam.
Awak pergi mana?
Saya lukis dekat pen.
Pin tu apa?
Software.
So awak boleh share? Software apa? Pin tak pernah dengar pun.
Paint, P-A-I-N-T.
Oh,
The
Paint.
integrated.
Sebutan dia paint. Okay. Kalau orang putih kat UK, what you mean? Masa saya dulu pergi UK gitulah, dia tak faham semua cakap, I see paint. Dia kata, oh it's paint. Dia kena ada, dia kena macam tarik sikit sabdu dia tu, baru dia, oh ya, paint. So boleh share?
Ya, madam.
Alah, 12.48 dah. Macam mana ni? Itulah bagi saya bagi tazkirah. So Azam, it's your fault. Choose me. Kerja ni jadi lama. Okay. Right. Tak boleh lagi. Payah sangat nak share ni.
Hang on a minute.
Orang lain? Dah siap?
Can I just show on top of the camera?
Tak tahu nampak ke tak? Tengok. Okay. Everybody can see? You agree with the drawing? Nak tunggu Azam share setahun. Okay. Sorry Azam. Sabar. You agree with this?
Yes, madam.
Semua draw benda sama?
Lebih kurang madam.
Okay, that's
One-
right.
One
Okay,
question, madam.
yes.
So gallium arsenide is the same, ada same material for the P and N, but do their band gap still like shifted up and down if we draw it?
So macam awak draw yang macam forward bias tu okay. You draw what is the bias that you are drawing?
Right. Yeah, this is forward bias. Yeah, sorry about that.
Okay, draw, betul soalan saya pun tak clear. Draw zero bias.
Forward bias.
Zero bias of that. Sebab saya tak kata apa-apa, mestilah zero bias. Kenapa buat forward bias?
I draw at
Because
zero
you
bias.
said,
Apa?
I draw at zero bias, madam.
Okay, mana share Azam?
Sekejap,
because I
madam.
follow the initial diagram that you draw earlier, madam.
Initial diagram?
The one that
yang
you
tu,
draw. For
yes.
that you share.
Yang tu dah forward. Tu dah forward bias kan
Yeah.
saya kata.
Sorry about that. Got the most fundamental one.
Orang lain? Hambali dah siap? Azam mana ni?
Madam. Saya share screen.
Cepat.
Are you using tablet or your mouse?
Ni madam.
Okay,
ni?
okay. Alamak, tak keluar apa. Okay, ada. Alright. Kosong.
Is it?
Kenapa tak nampak apa-apa? Mana gambar dia? Orang lain nampak ke? Oh, tak ada dah pula.
Entah dah, dia kelip-kelip lepas tu. Tak ada.
Okay. Orang lain boleh share? Zero bias. Kalau tak boleh share pun tunjuk macam macam Pak If tu je lah. Okay. Tunjuk kat kamera ni. Najwa. Cepat Najwa.
I like the word indium for some reason.
Hmm?
I like the word indium for some reason.
Okay. You are. Tu pelik tu. Okay. Alright. Najwa. Najwa. Allah. Dia tak nampak. Dia nampak awak kena buang background tapi. Back dia. Kita ada masalah lain pula. Hak tu tunjuk tak keluar gambar pin. Hak ni tak keluar terus. So siapa nak cuba lagi?
Kita
Okay.
madam.
Ha?
Saya lagi macam ni lah. Macam Faiz.
Macam Faiz lah. Okay. Do you agree everybody? What's missing?
Fermi level.
Apa? Apa? Fermi level, yes. You forgot to put the Fermi level punya tu. So because you have P, you have N, and don't forget another one intrinsic. Tapi biasanya intrinsic layer yang tengah tu kita tak lukis punya level je. Okay, so that's quantum well. Okay, so maknanya you can see the relative dimension yang tengah tu kecil. Now, 12.3. Tak apa, kita sambung next class. Okay, everybody remind me next class we'll talk about how the electrons are being confined in the quantum well and how is it working. Lepas quantum well kita akan pergi tengok quantum dot. So next time orang lain get ready for pergi test kira. Macam bagi saya kita habis ni. Okay. Alright, I think that's all for today. You can go and Google. There are a lot of videos on quantum well and quantum dot. Have a look first, and then cari yang short video. Biasa, you know what I do? Saya akan cari kat YouTube. Betul-betul you boleh filter short video kan, less than 3 minutes. Saya tengok yang panjang-panjang, tengok yang 3 minutes video tu je. Then you get the idea of quantum dot to quantum well. Okay, let's end the class today. Siapakah gerangannya membaca doa pada hari ini?
Saya, Madam.
Okey Azam. Go on.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala Sayyidina Muhammad wa ala alihi wa ashabihi ajma'in. اللهم اجعل جمعنا هذا جمعا مرحوما وتفرقنا من بعده تفرقا معصوما ولا تجعل اللهم فينا ولا معنا ولا من يتبعنا شقيا ولا مطرودا ولا محروما ربنا اغفر لنا ذنوبنا ولإخواننا الذين سبقونا بالإيمان ولا تجعل في قلوبنا غلا للذين آمنوا ربنا إنك رؤوف رحيم ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار صلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Alhamdulillahirabbil alamin. Thank you Azam. Let's end today's class. Selamat kita jumpa lagi sebelum puasa. Puasa hari Rabu kan? Itulah kita hari Selasa. So sama-samalah kita bersedia untuk Ramadan insya-Allah.
Ada. Yang ikut sebelum-sebelum ni tak terus lagi.
Oh, tak ada orang minta pun. Saya ni sibuk, awak kena remind. Saya ni lupa. So nanti awak remind dalam Telegram tu bila-bila, then I will upload. Okay, let's end today's class with tasbih kafarah and suratul Asr. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asr innal insana lafi khusr illa alladhina amanu wa 'amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr. Okay, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Madam.